The stress test results for the starboard actuator look good.
Agreed. Let's verify the pressure differential in Section 4 next.
Reads. Workers aged 22 to 25 move slowly among disassembled parts, and within that clean, quiet space, distanced as beavers. Many passengers believe that the future of aviation will be determined by higher speed or stronger engines.
Changing only a very small wing angle in the design can completely alter fuel consumption throughout decades of operation.
Many modern technologies do not appear suddenly, but were prepared years earlier inside the minds of the first designers. Split. Inside the maintenance hangar behind the terminal, where every procedure operates under absolute discipline, people begin towards. The narrow-body aircraft in matte gray metallic color, resting beneath white reflections on the polished metal. In those quiet moments, everyone begins realizing that aircraft design does not only determine the shape of a vehicle. The central question gradually becomes clear inside the quiet maintenance hangar about what truly makes design thinking under the normal operating state of aviation. Every aircraft is created to serve decades of continuous operation with nearly absolute stability.
Once a design is approved, it affects not just one aircraft, but thousands of flights over many decades afterward.
Even a small change in the way airflow moves around the aircraft body can save millions of liters of fuel throughout the aircraft's operational lifetime. Workers aged 22 to 25 continue inspecting every component according to standard procedures, because the entire modern
Inside the clean space behind the terminal, where the sounds of mechanical tools rise softly and quickly disappear, the narrow-body aircraft in matte gray metallic color are created according to the same principle that every detail must be easy to inspect, easy to maintain. The male engineer aged 25 to 30 points at the internal frame inside the aircraft wing and explains that many design decisions are made not to make the aircraft.
The female engineer aged 22 to 25 continues comparing component wear data and realizes that the easiest aircraft to maintain.
Under that standard operational state, aviation exists thanks to the ability to control risks before the aircraft ever takes off for the first time.
But right here, a major doubt begins to appear when many new technologies are constantly promoted as the future of aviation, even though most
Simply replacing the engine or adding modern electronic systems is enough to create a new future for aviation.
The male engineer aged 25 to 30 silently observes the load-bearing structure and explains that many modern aircraft still carry design thinking from decades ago.
Inside the clean, quiet maintenance hangar, the narrow-body aircraft in matte gray metallic color begin revealing a very...
Workers aged 22 to 25 continue replacing worn components and realize that many maintenance difficulties actually originate from the way the aircraft was designed from the very beginning.
A design lacking long-term thinking will make every future maintenance process far more complicated.
The male engineer aged 25 to 30 continues analyzing operational data and realizes that the most fuel-efficient aircraft are often not the
Inside the disciplined space behind the terminal, the question becomes increasingly clear that the future of aviation Workers aged 22 to 25 silently inspect tiny cracks on material surfaces and realize that some problems cannot be solved simply by adding technology afterward. Abel Simsigned. The greatest contradiction of modern aviation begins to emerge when the world wants aircraft to become more fuel-efficient.
The future of aviation does not begin when the aircraft takes flight, but begins when people decide how the aircraft itself should be conceived.
From that moment, the core reason gradually becomes clear inside the maintenance hangar behind the terminal, where the African-American female engineer aged 22 to 25 opens a digital structural model and demonstrates that if design
When aviation seeks to reduce carbon emissions, the issue is no longer about replacing the engine, but about redesigning the entire way the aircraft interacts with the air.
The easiest aircraft to repair are always the ones created with the mindset that maintenance is part of the design, rather than a task added later.
Inside that clean, quiet space, everyone begins understanding that true design thinking is the ability to see decades.
Materials themselves do not create the future, but rather the courage to redesign aircraft structures creates the future.
Analyzing the operational data demonstrates that the most effective changes in aviation history always begin with changing the core design philosophy.
Or sewn. The narrow-body aircraft in matte gray metallic color resting inside the maintenance hangar stand as proof that every curve, after the core reason becomes clear. The maintenance hangar behind the terminal begins revealing the difference between short-term design thinking and long-term design thinking. The narrow-body aircraft in matte gray metallic color with optimized designs usually require less maintenance time and maintain more stable performance throughout many years of operation.
The female engineer, aged 22 to 25, compares two different component arrangement systems and demonstrates that proper organization alone.
The Easton male engineer, aged 25 to 30, continues explaining that some aircraft are created for fast short-term operation but generate enormous maintenance pressure after many years of service. Workers aged 22 to 25 operate within the same technical zone and clearly feel the difference between a convenient design and a design that makes every operation difficult.
Race. Inside that disciplined, quiet environment, everyone begins understanding that design thinking affects not only engineers. The female engineer, aged 22 to 25, analyzes that aircraft designed with noise reduction in mind from the very beginning often provide a far more stable flight experience.
The male engineer, aged 25 to 30, continues pointing out that a good design can extend operational lifespan for many years without requiring changes to the core structure. Genches. The narrow-body aircraft in matte gray metallic color, resting beneath cold white industrial light, reveal the difference.
Workers aged 22 to 25 complete the final inspection step and realize that their work becomes much easier when the aircraft is designed with people-centered thinking.
Inside the quietness of the maintenance hangar behind the terminal, the future of aviation gradually appears not as a race for speed.
The future does not appear on the day the aircraft takes flight, but on the day the first design is created.
Every design decision made today will become either a limitation or an advantage for aviation over the coming decades.
Workers aged 22 to 25 move slowly among fully assembled components, as if they are walking. The narrow-body aircraft in matte gray metallic color resting inside that clean, disciplined environment make everyone realize that the future is not.
The female engineer, aged 22 to 25, confirms that the more modern aviation becomes, the more important design thinking becomes. The Hispanic male engineer, aged 25 to 30, looks across the entire maintenance hangar behind the terminal and concludes.
Workers aged 22 to 25 complete their shift in absolute silence and leave behind the image of an aviation industry being shaped not only by metal.
From inside the clean maintenance hangar behind the terminal, where narrow-body aircraft still.
The future of aviation always begins with aircraft design thinking before it begins with any other technology.